Okay, this tutorial is for section 4.6, and that's adding and subtracting of rational expressions, and we've got a couple of examples here that we're going to look at. And the one thing you'll have to remember about adding and subtracting is always, just like when we were doing fractions from grade 6, finding a common denominator. Okay, and then making sure that we do that correctly. Okay, with algebra, having x's and y's and different variables like that, finding a common denominator sometimes is a little more challenging. So we're going to look at a simple monomial example first. And what we have to do here is we have to be aware that we have to be finding a common denominator between 8 and 4, and x squared and x cubed, and y squared to get the total common denominator. So find the common denominator first. Now, it's easy with the x squareds and the y squareds and the y cubes and the x cubes and things like that, because the common denominator here between x squared and x cubed is just the lowest common denominator would be x cubed. Okay, because you just have to multiply by x to get it to x cubed for that other one. And same thing with y squared and y. It's going to be y squared. So it's the largest degree of it. And then we have to think here with the numbers, however, what is the lowest common denominator between 8 and 4? Well, that would be 8. So take the lowest common denominator and write it out. So in our case, it's going to be 8 x cubed y squared. That's going to be our lowest common denominator. Okay, so we can write that out for both fractions. Okay, so what do we have to multiply this denominator by to get the lowest common denominator? 8 was multiplied by 1, so that's no problem. We have to multiply by an x, and we have to multiply by a y. So that's what we also do on top. 5x multiplied by an x and a y, because that's what we have to multiply by. Here we look at same idea here, same common denominator. Now we look at this denominator and we say, well, what do we have to multiply the 4 by to get 8? 2. What do we multiply the x cubed by? Well, nothing, because there's x cubed there already, and nothing there as well because there's x squared there already, so 1 and 1. So then we just work this out. That's going to equal 5x squared y plus 6x all over 8x cubed y squared. I'm just putting it all over because it's the same common denominator. Okay, and if we want, we can take out a common factor here of x out in front. Now, because that'll help us reduce. Remember, it has to come out of both of those. And then we also have here pardon me, this is a squared here. So then we can cancel out one of these x's. So our final answer then is 5xy plus 6 all over 8x squared y squared. Okay, we're going to do another example here. I'm going to move up the field of view. And this one deals with binomials in there as well. So the first thing we got to do is factor. So this would mean a plus 5 and a minus 4. And this would mean a plus 5 and a plus 1. So we can see that the common denominator in this case is we'll have to, well, these ones already have a minus 5 as a factor, so that's going to be one of the factors. Okay, so take all the factors that'll be in there. A plus 5 is in both, so you don't have to repeat it twice. And A minus 4 is in that one, and A plus 1 is in that one. So that's your total common denominator. So what you do is you write that thing out as your common denominator. Then we take a look and see what's missing. Okay, this denominator has both of these but misses that one. So we need to multiply by the missing part up here so that we don't change the expression. We multiplied by a plus 1 on the bottom. We've got to multiply by a plus 1 on top. In this case, we multiplied by a minus 4 on the bottom to get the common denominator. So we have to multiply by a minus 4 on the top so we don't change the expression. And then we just simplify. So that would be 2a squared plus 2a minus 3a plus 12, all over a common denominator. Okay, again, there are going to be restrictions here as well. If you're looking at these factored expressions here, we have some restrictions as well, just like with our multiplying and dividing. I forgot to mention that up here, that the x and y's cannot equal 0. Okay, just continuing on here. Simplifying this one. We get this expression. And of course, a cannot equal -5, +4, or -1 in any of those cases there. Because that would make this expression 0 on the bottom, making it undefined. Okay, I don't have enough time to do a third example, but I will do that in my next tutorial that deals with this similar type of problem as this one here.